All right, I've got three kind of higher level normal distribution problems. They're going to be inverse normal distribution problems as well. Some people call them bounds. But let's just get stuck in. So I've truncated the problem down so there's not too many words. So Nutty snack bars, okay, their weight is normally distributed, so that's good. So it's a normal distribution problem. The mean of these Nutty snack bars is 41 grams. So the mean, or mu, is 41. The standard deviation is only 0.8. It's pretty small. It's what you want in a factory. It is 0.8. Now, between what weights will the middle 60% be? So the middle 60%, we want to find these values. So the middle 60% must be 30% on one side and 30% on the other. So let's figure out how many standard deviations away 30% is. So we get this, and we're looking for 30%. So I'm looking here at 2995, and I can't go outside of 30%, so I can't go to 3001. So I can't add the 6, but I can add the 3 and get 2998. So how many standard deviations away is 2998? It is 0.841. 0.841. 0.841. So Z is 0.841. So we know that we do have an equation that can relate Z with X. Z is equal to X minus mu over the standard deviation. So let's figure out this positive X value first. So 0.841 is equal to X, the unknown value, minus the mean, 41, over the standard deviation. So now all we have to do is rearrange for that X value. Okay, so 0.841, we're going to times by 0.8, and we're going to add 41. So 4167. All right, so we're going to start our sentence between 41.67 grams, and we need to go in the opposite direction, so we need to do this for negative 0.841 as well. Okay, so negative 0.841 times 0.8 plus 41, because the order of operations there, they do matter, but it's pretty easy. So 40.32. And 40.32 grams. So between what weights will the middle 6% be between? 41.67 grams and 40.32 grams. Probably makes more sense to write those around the other way. Go from the smaller one to the bigger one, but that's how you do that problem. I've got two more for us to do, just to make the video a bit richer than just that one problem. Hopefully that makes sense. You can always pause and give these problems a go as well if you haven't seen them yet. So scores on a math test are normally distributed. Great, so I draw my normal distribution. I mean, it doesn't need to be that pretty, it just needs to make sense to me. There's a mean, the mean score is 65%. A weird problem because it's the percentages are actually the scores. And there's a standard deviation of 9. So mu 65. Only the top 85% of students are permitted to take maths next year. So the top 80%, 85% would be this 50% and this 35%. And we're going to just try and find that one value. So we're looking for 35% on our normal distribution. 35%. Well, we can't go more than 35. So we're going to have to go just under. So 3485. The most I can add is 15. And there's a 14 there. So 1, 3, 1.036, 1.036, 1.036. That is the number of standard deviations that make 35% according to this table. So now I need to solve for the x value. 1.036 is equal to negative, because we're on the left, minus 65 over 9. So let's get the calculator out. Negative 1.036, didn't put a decimal, negative 1.036 times 9 plus 65, 55.67. What way can I round that? I'm going to have to round that up, aren't I? I can't round down because I'm going to now get more than 35%. So 55 point, I have to round it up to 7. X equals 55.7. Above 55.7% will be admitted to maths next year. Cool. Hopefully that makes sense. Right, third one, I've got quite a tricky one. Hopefully I don't run out of paper here. I might have to get some more in. So a school runs a math competition. The top 2% are awarded an outstanding. So this, I'll make it quite large, but this 2% here get an outstanding. The next 5% are awarded distinction. So this, I probably should have drawn this one bigger. This 5%, these get distinction and these get outstanding. The grades are normally distributed for a mean of 25 and a standard deviation of 6.1. Now we want to find what range of values, so x1, x2, what are these two values that are going to give a grade of distinction? Okay, well, we want to find the value of x that's going to give us a area in here of, take away 7, 43%. So let's just find this first x value. So 43% and nothing more. So let's just check our rounding. We don't want to go above 43. So we're looking for 43. All right, here we go. It's just over. We're going to have to go to 42.92. Oh, we're going to get perfectly on the 43 actually, because if we add the 8 on, we're going to get 4300. So that is 1476. I'm going to need to use a ruler there and remember that. So we're looking for 43, 1476, 1476, 1476. That's how many standard deviations 43% are. So 1.476 is equal to that unknown value x, so I'm going to call it x1 because we're trying to find a range of values, minus the mean all over the standard deviation. Now I'm just going to rearrange for the x1. Now you're going to probably want to show you working for this, but for the sake of keeping the video short, 1.476 times 6.1 plus that 25 after rearranging, 34. Now I can't round that down because that's going to make it more than 5%. So I think in this context, I think it's fine just to call that 34. Now we need x2. x2 is just going to be this total area, the 43, and that 5, that's going to give us all of this area, which is what we want to find in our z table, or our normal distribution table. So we're looking for 48%. Okay, 48%. Here we go. Can I add a 2 on? I can. So we've got two options here. We will go with the first one, 2.054. 2.054. That's the number of standard deviations. for x2. So 2.054 is equal to x2 minus 25 over 6.1. Rearranging, 2.054 times 6.1 plus 25, 37 point. Now how could we round this? We can't round this up because those people will get outstanding. Let's just call it 37. We'll round it down to 37.5. 37.5. So there we have it. Those are the 2 marks that you need to be between to get distinction in this maths test. Cool. Hope that makes sense. The good thing about a video is you could always watch it again.